Good day everyone. Today we're going to tackle the following topics. Basic integration formulas, logarithmic function, exponential function, trigonometric function, algebraic function. To start off the lecture, we will begin with the logarithmic function. Now let's recall our formula from the derivative of d over dx ln x is equal to 1 over x. In logarithmic function, it doesn't use the power formula. The formula of the logarithmic function is the integral of a over x dx is equal to a ln the absolute value of x plus c. For the example, for number 1, the integral of 2 over x plus 1 dx. We're simply gonna follow the formula. We're going to put the constant 2, the integral of 1 over x plus 1 dx. The next is 2 ln the absolute value of x plus 1 and add the constant. This is your final answer. For example number 2, we're going to solve the integral of 3 over 2x plus 4 dx. We're going to factor 2 out. So, the integral of 3 over 2 times x plus 2 dx. Since we have the constant 3 and 2, we're going to put it out. 3 over 2, the integral of 1 over x plus 2 dx. And the final answer will be 3 over 2 ln absolute value of x plus 2 and add the constant plus c. And that's it. That's for the logarithmic function. For exponential function, we're going to recall the derivative of the exponential function, which is d over dx e raised to bx is equal to b times e over bx. The formula will be the integral of e raised to bx dx is equal to e raised to bx over b plus the constant. Let's have an example. For number 1, we're going to solve the integral of the square root of x minus 2 minus 1 over x minus 4 plus 10 raised to x dx. Using mental solving, we're going to write x minus 2 raised to 3 over 2 over 3 over 2 minus the ln of the absolute value of x plus 4 plus 10 raised to x over ln 10. Next, since we have the constant, we're going to put 2 over 3 times the value of x minus 2 raised to 3 over 2 minus the ln of the absolute value of x plus 4 plus 10 raised to x over ln 10 plus the constant. For number 2, we're going to solve the integral of 1 over e raised to the power of negative 3x dx. What if the exponential function is in the denominator? We're going to simply transpose it. So, it will become the integral of e raised to negative 3x dx. And the integral of that is e raised to negative 3x over negative 3 plus the constant. And that will be for the exponential function. For trigonometric function, we need to recall d over dx times sine bx is equal to b cosine dx. And d over dx cosine bx is equal to negative sine bx over dx. And the formula of integration trigonometric function is the integral of sine bx dx is equal to negative cosine bx over b plus the constant. And the integral of cosine bx dx is equal to the sine bx over b plus the constant. For the example, we're going to solve the integral of cosine squared x dx. So we're going to start with the integral of one minus sine 2x dx. One minus cosine 2x raised over 2 dx. The integral of 1 minus 1/2 plus cosine 2x over 2 dx. The integral of 1/2 plus the cosine 2x over 2 dx. We're going to simplify 1/2 x plus 1/2 times sine 2x over 2. Your answer will be 1 over 2x plus 1/4 sine 2x plus the constant. For number 2, I'm going to solve the integral of sine 3x plus cosine 4x plus second raised to 2 x over 2 dx. Using mental integration, we're going to have negative cosine, copy 3x, 3 minus sine 4x over 4. The equivalent of second is tangent, so we're going to put tan x raised to 2 over 1/2 because x raised to 2 is equal to 1/2. Okay. Next, we're going to simplify. Negative 1 over 3 cosine 3x minus 1/4 sine 4x plus 2 tan x over 2 plus the constant. And that's all for the trigonometric function. Lastly, for algebraic function, we have the power formula, which is in the integral of ax raised to n dx equals to a, the integral of x raised to n dx equals to a times x over n plus 1. Oh, don't forget the n plus 1 here plus c. Okay. For the example, we're going to solve the integral of 5x raised to 3 dx. First of all, we're going to put 5 here. Then the integral of x cubed dx. X, you add 1, don't forget the 1. So x raised to 4 over 4 plus c plus the constant. And your final answer will be, or you can write it this way, 5 over 4 x raised to 4 plus the constant. Okay. The integral of, for number 2, the integral of the square root of x plus 3 square root of x dx. So we're going to the integral of x raised to 1/2 plus x is 1/3 dx plus 1. So we're going to x raised to 1/2 plus 1 over 1/2 plus 1 plus x raised to 1/3 plus 1 over 1/3 plus 1. And your final answer will be x raised to 3 over 2 over 3 over 2 plus x raised to 4 over 3 over 4 over 3 plus the constant. And that's it for algebraic functions. For this topic, we're going to discuss the general integration formulas and u substitution. The learning objectives will be the general integration, or known as the power formula, and the next one is u substitution. In the general power formula, it consists of 4 formulas, which is the integral of u raised to n du is equal to u raised to n plus 1 over n plus 1 plus the constant. And it won't be useful if n is equal to -1. If not applicable by -1, use logarithm. So the integral of du over u is equal to ln and the absolute value of u plus c. The other one is the integral of e raised to u du equals to e raised to u plus the constant. Lastly is the integral of a raised to u du is equal to a raised to u over ln u plus c. The u substitution examples. For number 1, we're going to solve the integral of 3t dt over 3 square root of t squared plus 3. So we're going to by 3 over 2 integral of 2t dt over t squared plus 3 raised to 1/3. So we're going to use this. Let u substitute u to t squared plus 3 and du substitute to 2t dt. Okay. The following step will be first of all, we're going to substitute this like this. 3 over 2 integral of du over u is to 1/3. Okay. So we're going to copy and substitute 3 over 2 the integral of u negative 1/3 du. Okay. It's going to be 9 over 4 u 2/3 plus the constant. We're going to simplify by 9 over 4 times t 2 plus 3 raised to power of 2 over 3 plus the constant. Okay. For number 2, we're going to solve the integral of e raised to negative x squared plus 2x dx. First of all, we're going to substitute. Let u be 1/2. The equivalent of 1/2 is x negative raised to negative 2. And du will be negative 2x raised to 3 dx. Simplify, negative 2 over x 3 dx. Okay. For the first thing you should do is substitute and copy to negative 1 over 2 times the integral of e raised to u du. Copy 1 2 u plus c, and we're going to simplify it by using negative 1 over 2 e raised to 1 over x squared plus c, and that will be your final answer. For the last lesson, we will be discussing the integration by parts. These are the techniques for integration. They use substitution, trigonometric transformation, and integration by parts, which is our lesson for today. If you recall, the derivative of the product, meaning d times u and v, is equal to u dv plus v du. If you want to solve u dv, we need to transpose it on the other side, which is what we will do here. The integral of u dv equals to the integral of d times uv minus the integral of v du. And integrate both sides, we're going to have the integral of u dv equals uv minus the integral of v du. And this will be your formula. For the example, we're going to have the integral of x sine x dx. So, we will follow the formula, which is our u will be x, our du will be dx, our dv will be sine x dx, and our v will be negative cosine x. Okay. Following the formula, we will substitute the given. It will be negative x cosine x minus the integral of negative cosine x dx. Copy the first term, negative x cosine x. Negative times negative is equals to positive. So the plus the integral of cosine x dx. For the final part, we will simplify. Negative x cosine plus sine x plus the constant plus c. Okay. For number 2, we're going to solve the integral of arctan x dx. Okay. We will follow what we did for the number 1. Our u will be arctan x. Okay. Our du will be dx over 1 plus x squared. Our dv will be dx, and our v will be x. By following the formula, we will substitute x arctan x minus the integral of x over 1 plus x squared dx. By simplifying it, we will have the answer of x tan x minus 1/2 minus 1/2 ln the absolute value of 1 plus x squared plus the constant plus c. Okay. I'll adjust this. For number 3, we will solve the integral of x squared e raised to negative x dx. Again, let u be x squared du x dx, and our dv will be e raised to negative x dx, and our v will be negative e raised to negative ex. By following the formula, we will substitute, meaning negative x squared times e raised to negative x plus 2, the integral of x e raised to negative x dx by using 2 transpose 2 e raised to negative x plus 2 So the integral of this, and by simplifying it, we will have the answer of negative x squared e raised to negative x minus 2x e times e raised to negative x minus 2e raised to negative x plus the constant plus c. And that will be all for our lesson today, and I hope you learned